Welcome back to the experimental sessions for the course Elementary Electrochemistry. In the previous videos, we have demonstrated two experiments of potentiometric titrations, one using strong acid and strong base, that was with HCl and NaOH, and the second one was a weak acid and a strong base, that is acetic acid versus NaOH. So now in this third experiment, I am going to use a weak dibasic acid, which is here. This is oxalic acid dihydrate, approximately N by 100 strength. As usual, this is a very dilute solution of approximate N by 100 concentration, and I am going to titrate this using the standardized N by 10, approximately N by 10 NaOH solution. So this NaOH solution is 10 times more concentrated with respect to that oxalic acid. So what do we expect here is that oxalic acid, when it reacts with NaOH, its two carboxylic acids will deprotonate stepwise. So we should get two minute jumps in my potentiometric titration graph when we plot the volume of NaOH versus pH. So to start, we need to use 10 ml of pipette with a pipette pump. I will use this 10 ml pipette to pipette out 10 ml of this approximately N by 100 oxalic acid solution and transfer it to the beaker in which we will do the titration, and we have the pH electrode inserted in that beaker. As you will see that this 10 ml of acid will not be sufficient enough to dip the electrode completely in within the solution. So after transferring this acid, we will have to add about another 20 to 25 ml of water to make the entire electrode dipped, the tip of the electrode dipped inside the solution for measurement of pH. We first try to lower it as much as possible, so that we need to add a minimum quantity of water. The electrode should start reading the pH and should be displayed in the meter, as you can probably see in the inset. So with just addition of about 20 ml of water, the electrode is completely dipped and we are ready to start the titration process. So before addition of any NaOH, that is at zero volume of NaOH, the pH is 2.70. Now I am going to start adding NaOH slowly in a step of 0.02 ml as before, and we will shake the solution, start the solution and homogenize it before taking the reading. So after addition of 0.02 ml of NaOH, the pH has not changed much, it remains at 2.68. So we should continue this addition as before, which we have already done for strong acid and strong base, and then for weak acid and strong base. Right. So with addition of 0.04 ml of NaOH, now the pH has slightly increased to 2.83. So we will continue to add as before 0.02 ml further of now we have added up to 0.1 ml of NaOH and the pH has changed to 2.87. So it is slowly increasing as we expect. We have been adding 0.02 ml each step and now we have reached 0.2 ml and the pH has increased to 2.94. So we will again continue addition of 0.02 ml at a time and keep taking readings till we start see a significant increase in pH. Now we have reached 0.34 ml and we can see that the pH has increased to 3.10. So the increase is continuous and in a regular manner. So we have now added 0.4 ml of NaOH and shaken the mixture. It has reached equilibrium, and we can see that there is an increase up to 3.15. See, these readings may not look significant for you when you are doing the experiment, but when you plot the delta pH versus volume of NaOH, you will see that there is a point which we are approaching now, which will indicate the half equivalence point, that is the first part of oxalic acid, that is you have two carboxylic acid groups, one carboxylic acid is completely deprotonated to monooxalate. So at that point the pH will increase more than the previous readings. So we need to note down that reading very carefully. Now you can see that we have reached 0.5 ml, which is about the halfway. I am not 100% sure, but this could be the point from where there will be a certain jump in pH, because we are now very close to the neutralization of first oxalate, first carboxylate and of carboxylic acid of the oxalate oxalic acid. So the pH is now 3.29. Now we have added another 0.04 ml this time, and we have reached 0.54 ml and pH is 3.35. So the increase is like 0.05, 0.04 in pH, that is happening almost constantly. Now I have reached 0.60 ml and the pH has now jumped to 3.44. So what you see is that there is a jump in pH by 0.09, which is important. When we plot delta pH versus volume of NaOH, these differences will become evident. So now we have reached 0.64 ml and pH is 3.53, which is again a jump of about 0.9, which indicates that we are close to the half neutralization point. We have added another 0.04 ml, so we have reached 0.68 ml and the pH is 3.59. So what you see here is there was a small region where the delta pH increased from increased initially by 0.04 and then 0.06 and then 0.09, and now again the increase is just about 0.07, and with the next addition I presume that it will be again less than 0.07, which will then indicate that we have just crossed the half neutralization point. So now we are at 0.72 and the pH has changed to 3.67, which is like 0.08 in terms of pH. Now we have reached 0.74 and pH is 3.72. So we have just crossed the half equivalence point, and then we should continue as usual till we see a jump above pH 7, which will indicate the complete neutralization point. Now we have reached a point of 0.90 ml, that is now the pH is 4.09, where we can see that again the pH is starting to increase because we are now nearing the complete equivalence point. So we have added up to 1 ml now, and with 1 ml it is 4.27. Now we have reached a point of 1.20 ml, and the pH that we can see is 4.85. The accuracy of this experiment depends on how close your readings are with respect to the amount of NaOH added. So we should always add 0.02 ml in each step, so that our delta pH versus delta V plot is done very accurately, and one can determine the end point or the equivalence point accurately. Now, by stepwise addition, I have reached a point where I have added 1.30 ml and the pH reads 5.38, which now indicates that the S type of curve has started going upwards. So, to draw the curve very nicely, one should have readings with very small difference in the volume of NaOH added. That is, we should now use again 0.2 ml steps at a time. So with just addition of 0.02 ml of this NaOH, which is 10 times stronger, has increased the pH from 5.38 to 5.83. So we continue addition of 0.2 ml, 0.02 ml each time and mix it well so that the solution is homogeneous, and the pH that we read is the pH of the solution and not a local pH. So what you can see is that now with 0.02 ml addition of n by 10 NaOH, the pH that is increasing in the order of 0.4. Earlier reading was 5.83 and now it is 6.23. .38 ml is now added and the pH is still increasing because it has not homogenized yet. So we should stir it well for a longer period of time to homogenize so that the pH meter can read the correct pH. So 6.69, it is still increasing, it is going very close to 7, which essentially indicates that now we are very close to the equivalence point. 6.73 should be our reading. So now I am guessing that with one more drop of NaOH, which will take us to 1.4 ml, we will have a jump in pH and the end point will be reached. So with 1.4 ml of NaOH added, our pH has now crossed the mark of 7, so it is now 7.08. Remember that the actual end point will be calculated when we plot the delta pH versus volume of NaOH, and where there will be a peak in that plot, that will indicate the end point. So here, by looking at these readings, I can guess that the end point will be somewhere between 1.34 and 1.38, because the jump there is about 0.5 ml, jump of pH is about 0.5, and in the previous case the jump was 0.4. And then again from 6.73 to 7.08, the jump is about 0.3. So the increase, that is the delta pH versus VNaOH, the increased delta pH is reducing now. So somewhere in this region we will have the end point. So when we plot, we will be able to see it better. So by continuing addition of 0.04 ml in each step, now I have reached 1.5 ml, and we can see that we have crossed pH 7 and reached a value of 8.22. It is still increasing, still homogenizing the solution. So we should stir it well so that the solution becomes homogeneous quickly and the pH meter can read the correct pH. We take this value as 8.55 and then continue adding more NaOH till it reaches about 10. I have reached 1.54 ml and pH is 9.4644, 9.46. So we continue for another 3 or 4 readings. I am sure with that we will reach about 10. So now we have added 1.58 ml and pH has now reached 9.86. So it is going very close to 10, and you see that the difference in the consecutive readings is now decreasing slowly. Now we have reached 1.60 ml and pH has just crossed 10. So I think we can do 2 or 3 more readings and then stop this experiment, because now we have reached a situation where towards the top the pH is now slowly stabilizing at about 10. So with these data points we will be able to draw a nice S-type curve. So now in two steps I have added 1.64 and then 1.68 ml of N by 10 NaOH, and I have reached a pH of 10.33. So if you look at the consecutive last few readings, the increase is now very small. So with one more reading with 1.7 ml, we will end this titration and then go back to the bench and draw the curve for this experiment. So now I have added just 0.02 ml of NaOH to end this titration, and the pH is 10.39. So what we see is the increase towards the end has now again reduced back to a difference of 0.05 or 0.06 ml, 0.05 or 0.06 in pH, and that is where one should stop this titration and use this entire data to plot the volume of NaOH versus pH, and also delta pH versus volume of NaOH, and see how the S type of curve comes for three different acids. One should actually try to plot these data in the same graph paper and compare them quantitatively together and see how the shape of that S curve is different from strong acid strong base to weak acid strong base to a weak dibasic acid to a strong base. So I will discuss this during the theory class with the plots that we would generate from this data, and we will have a complete discussion after the experiment is over today. So with this we end first part of our experimental discussion using potentiometric titration. This will be followed by the calculations, graphs of these experiments, and we will conclude the week with those data. And in the next week we will have experiments, next time we will have the experiments related to conductometry and conductometric titrations. Thank you.